Well, in this session, we are going to talk about derivative of a function in parametric form. First of all, let's try what a function in parametric form is. See, we have studied the functions where y can explicitly be represented in form of x. And we have studied those functions where y couldn't be expressed in the form of x explicitly, that is, implicit functions. But sometimes it happens that the function is neither implicit nor explicit. But the variables are related to each other, connected to each other with the help of a third variable, and that third variable is known as parameter. Means here x will depend on some parameter t and y also will depend on that same parameter t, and there is no direct relationship between x and y is given. In that case, we have to find the derivative. See, if I am given x as a function of t and y is another function of t, and we need dy by dx. If I try to find dy by dt by chain rule, introducing x dy by dx into dx by dt, this is simply chain rule. Dy by dt is equal to x, y depends on x, so dy by dx into dx by dt. From here, it is very evident that I can find the value of dy by dx. And what is the value of dy by dx? Simply derivative of y with respect to t divided by derivative of x with respect to t. So if I am given a function in parametric form, what I need to do is simply differentiate y with respect to that parameter, also differentiate x with respect to that parameter, and divide the derivative of y with respect to t by the derivative of x with respect to t, y upon x dy by dx. Let's take a simplest example. See, if I am given a question, x is equal to a cos theta, y is equal to a sin theta. Actually, it is the parametric equation of a circle. How? If you try to eliminate theta between these two, so you can find the value of cos theta from here. Cos theta is x upon a and sin theta is y upon a. If I square and add, that is sin square theta plus cos square theta is equal to 1. That gives me sin square theta is y square upon a square plus x square upon a square is equal to 1. If you take the if you multiply both the sides by a square, what you get is x square plus y square is equal to a square. So this actually is the equation of a circle. So you can eliminate the parameter. Suppose it is x is equal to a cos theta and y is equal to b sin theta, then actually it is the equation of an ellipse. See how here in this case this will be y upon b. So this y upon b square. So x square upon a square plus y square upon b square will be equal to 1. So this is the equation of ellipse. So here we are not going to eliminate, we will simply use the derivative in parametric form. Let's see how it works. So what we need to do is we will differentiate both x and y with respect to theta. So differentiating with respect to theta, we get dx by d theta. The derivative of cos theta is minus sin theta, and dy by d theta, we differentiate this with respect to theta. So a is a constant, the derivative of sin theta is simply cos theta. Now we know that dy by dx, the differential coefficient of y with respect to x, is given as derivative of y with respect to t divided by derivative of x with respect to, sorry, here the parameter is theta. Alright. So this gives us dy by d theta is a cos theta upon dx by d theta is a sine theta, minus a sine theta in fact. A will be cancelled out, then this gives us cos upon sine, that is minus cot theta. That is the answer. So if the dependent variable and the independent variable are connected with a third variable, that is a parameter, then what we need to do is we will separately differentiate x and y with respect to that parameter, and we will simply apply derivative y with respect to x is nothing but the ratio of derivative of y with respect to that variable and x with respect to that variable. Let's take some interesting question on this topic. See, I have taken the question from exercise 5.6. Let's take. This is a very interesting question. Well, differentiating with respect to t, we get. Let's see. dx by dt, derivative of x with respect to t. A is a constant. The derivative of cos t is minus sin t. The derivative of log of u, that is 1 upon u. We apply chain rule here. 1 upon u into the derivative of tan t by 2, that is nothing but sec square t by 2. And the derivative of t by 2 with respect to t is half. Well, so this is a times of minus sin t. We change all the expressions in terms of sine and cos. So what we get is tan t by 2 is nothing but sin t by 2 divided by cos t by 2. The sec square t by 2 is simply 1 upon cos square t by 2, and here we have this 1 by 2. So a power of cos t by 2 will be cancelled out. This will give us a times of minus sin t plus 1 upon this 2 sin t by 2, cos t by 2 is in the denominator, 2 sin t by 2 cos t by 2. This 2, then sin t by 2 and cos t by 2. We know that 2 sin theta cos theta, 2 sin theta cos theta, 2 sin t by 2 cos t by 2 will simply be written as sine of t, as we know that 2 sin theta by 2 cos theta by 2 will give us sine theta, sine 2 theta double angle. Here theta by the double of theta by 2 is theta. Now if we take LCM, what we get is sin t minus sin square t plus 1, and in fact 1 minus sin square t, the numerator can be seen as 1 minus sin square t upon sin t, and we know that 1 minus sin square t is cos square t. So this is a cos square t divided by sin t. Let's talk about y. Y here is equal to a sin t. Now y is equal to a sin t. So now on differentiating, so derivative of y with respect to t is equal to a is a constant. The derivative of sin t with respect to t is simply cos t. Now we have derivative of y with respect to x is simply derivative of y with respect to t divided by derivative of x with respect to t. Simply derivative of y with respect to t we just have found. This is derivative of y with respect to t, that is a cos t. And if I talk about derivative of x with respect to t, this is derivative of x with respect to t. Let's put the values. So derivative of y with respect to t is a cos t, okay, and derivative of x with respect to t is simply a cos square t, a cos square t divided by sin t. Obviously, one power of cos will be cancelled. Also, a can be cancelled out. This cos can be cancelled out on solving. What we get is sin t upon cos t. Is sin t upon this cos t. So, d derivative of y with respect to x, and finally derivative of y with respect to x. Derivative of y with respect to x is sin t upon cos t, is nothing but tan t. So we can see it includes some trigonometry, and one of the best questions, if you can see, simply on differentiating, we will get this log of tan t by 2 is the differentiation of log of tan t by 2 is 1 upon tan t by 2 into derivative of tan t by 2, that is sec square t by 2 into derivative of t by 2 is half. If we change it to in terms of sine and cos, what we get is 2 sine theta by 2 cos theta by 2, and 2 sine theta by 2 cos theta by 2 is simply sine theta. So this and 1 minus sine square can be written as cos square t. So a bit of trigonometry will help to simplify the answer, and the final answer is tan t. Let's take some more questions. Well, here is a question. Now what we need to do is we'll simply differentiate x with respect to theta, also y with respect to theta, and we'll divide the derivative of y with the derivative of x. So on differentiating, see dx by d theta. Here the parameter is theta. So a is a constant. Now we differentiate the derivative of cos theta is simply minus sine theta. Here the product rule will be applied. U into v. Theta same into derivative of sine theta. So theta same into derivative of sine theta is cos theta, plus this time sine theta same into derivative of theta with respect to theta is 1. So this will give you a times of minus sine theta plus theta cos theta minus plus sine theta. On opening bracket, theta cos theta plus sine theta. The sine theta will be cancelled out. This will give us a times of theta cos theta. Now we talk about y. dy by d theta. Let's differentiate y with respect to theta. Here is our y. So if we try to differentiate it, a same, the derivative of sine theta is simply cos theta minus, now the derivative of theta cos theta. Here the product rule will be applied. Theta same into derivative of cos theta is minus sine theta, plus this time cos theta same into derivative of theta is 1. Product rule, theta same into derivative of cos theta gives us theta into minus sine theta. This time cos theta same into derivative of theta is 1. So this gives us simply a times of cos theta minus into minus will plus theta sine theta, then negative cos theta. Well, this cos theta will be cancelled out, and we get derivative of y with respect to theta as a theta sine theta. This is derivative of y with respect, derivative of x with respect to theta. You may put it equation 1, and this is derivative of y with respect to theta. This can be written as equation 2, and what we need is we need derivative of y with respect to x. So derivative of y with respect to x is derivative of y with respect to theta divided by derivative of x with respect to theta. That is a theta sine theta upon a theta cos theta. A and theta will be cancelled out. Sine theta upon cos theta is nothing but tan theta. So this is how we find the derivative of a function in parametric form. Here x and y are not directly connected. They are connected with the help of a third parameter. Let's take one more question. This. See, we can eliminate t here because we know sine inverse t plus cos inverse t is always equal to pi by 2. Well, so if I square, because the answer is given in terms of x and y, so it is better to eliminate t between these two equations. On squaring, what we get? On squaring, we get x square is equal to a times a raised to sine inverse t, and y square is a raised to cos inverse t. We know that sine inverse t plus cos inverse t is always 1. So if we multiply these two, on multiplying, the left hand side will be multiplied by the left hand side. So x square into y square is equal to the right hand side is multiplied by right hand side, or simply the product x square y square is the product of these two. A raised to sine inverse t into a raised to cos inverse t. Well, we know the property law of exponent. A raised to m into a raised to n is equal to a raised to m plus n, and that solves our purpose. If we add sine inverse t and cos inverse t, what we are going to get is a constant pi by 2, and the derivative of pi by 2 is 0. That is, we eliminated t from here. See how? X square y square is equal to a raised to sine inverse t plus cos inverse t. We can see the base is same. When the base is same, exponents will be added. And we know that sine inverse t plus cos inverse t is always equal to pi by 2. So what we got is x square y square is equal to a raised to pi by 2. Now we have got a relation between x and y. On differentiating, we will get the answer. On differentiating with respect to x, we have eliminated the perimeter. So now we are differentiating with respect to x. So here the product rule will be applicable. X square same into derivative of y square with respect to x is 2y dy by dx plus y square same into derivative of x square with respect to x is simply 2x is equal to the derivative of a raised to pi by 2 is 0 because it is a constant. It do not involve variable. Okay, so this gives us 2x square y dy by dx is equal to minus times of 2xy square. Well, we need dy by dx, derivative of y with respect to x. So derivative of y with respect to x is equal to minus 2xy square upon, sorry, it was to prove dy by dx is equal to minus times of y by x. The question is minus times of y by x. Okay, minus 2xy square upon 2x square y. This gives us derivative of y with respect to x is equal to minus times of y by x. 1 power of x will be cancelled out, 1 power of y will be cancelled out, 2 will be cancelled out, and this will give us derivative of y with respect to x as minus y by x. We can solve it by direct method. What we do is we will apply the function of function. Here also we will apply the chain rule. We will derivate it as a function of function, and then in the same manner dy by dt, but that will be a lengthy process. It's better to eliminate. See, in the very first question when we talked about parametric form, x is equal to a cos theta, y is equal to a sin theta. It is nothing actually but the equation of a circle. if you try to eliminate theta between these two, that means you find the value of sine theta and cos theta and then square and add sine square theta plus cos square theta is 1. So this gives us x square plus y square is equal to a square. In a similar manner, the parametric form of a parabola is x is equal to 280, y is equal to 80 square. You can derive it in terms of t, but if you try to eliminate t, find the value of t from equation 1. T is equal to x upon 2a. Well, put this in equation 2. So y is equal to a times of the square of t, that is the square of x upon 2a. Square of x upon 2a. If you expand it, what you find is y is equal to a times of x square upon 4a square. 4a square. The one power of a will be cancelled out, and this is nothing but if I multiply 4a by this side, 4ay is equal to x square, that is x square is equal to 4ay. This is parabola, upward parabola, x square is equal to 4ay. If you take x is equal to 80 square and y is equal to 280, what you are going to get? You are going, if you try to eliminate x from t from here, you will get y square is equal to 4ax, the parabola. So it can be done in two manners. One, you can eliminate the perimeter and you can get the Cartesian equation between x and y, and you can derive, or simply you can proceed in the parametric form, and in parametric form, derivative of y, let me write it here, derivative of y with respect to x can simply be written as derivative of y with respect to that parameter divided by derivative of x with respect to the parameter. That is all we need to do while finding the derivative of a function in parametric form. Thank you. Now you can do exercise 5.6. Thank you.